Hi, my name's John. Welcome to another Sunday night nightcap. In tonight's nightcap, you've got the usual mixture of machining, welding, and hopefully a little bit of a joke and a bit daft carry on, because basically that's what it's all about, enjoying yourself and having fun. I've always tried to make this YouTube channel or this YouTube environment a friendly place. I've had one or two nastiest comments posted. I don't know what's going on with that. People are possibly jealous or I don't know, but if somebody's got a problem with me, we can always have a meeting and sort it out. You know, it's not a big problem anyway. I just thought I'd get that off my chest. It just niggles and winds us up a little bit. Anyway, back on with the nightcaps. In tonight's nightcap, I make it's actually a grease nipple adapter for a grease nipple and an old Sentinel steam wagon. Quite an elaborate affair, a little bit of screw cutting, a little bit of welding, lots of machining. I hope you find it interesting. I've had some more double boost hats embroidered, so they're back on sale. That's the eBay item number up there. If you want one, go and have a look. I'd like to say a big thanks to my friend Lee, who came up all the way from Durham to help us set up the Arc Droid. Lee certainly knows his way around them. We've got it working, no problem at all. And the new plasma cutter also come from Artec, so I'm looking forward to having a bit go with that, and hopefully I'll show you some videos up by next weekend. This interesting looking device here is actually a grease nipple of a Sentinel steam wagon. The grease gun screws onto there, it seals on that taper there, and there's a little ball and spring in there like an on-return valve, and I've got to make the part that fits onto there. It looks like a Whitworth thread. Chances are it will be Whitworth, being on a Sentinel steam wagon. It appears to be round about 7/8 in 10 TPI. Fits in perfectly, so it is 7/8 Whitworth. I hope you can see that. Focus, you bastard, you. Right, so that's as good as we're going to get. That's the little bit of plastic I used to make the template for the last thread with screw cut. I'll be able to get that out of there, so I'm going to screw cut this in the lathe, make sure it fits on there, then we'll make one out of steel and then form some sort of adapter to go onto there, and then I've got a nice new hose to go into a conventional grease gun. I've never seen anything quite like that before. The threads are damaged, but it is what it is. It's just got to be it's like a screw-on fit, and it'll hopefully seal around there somewhere, seal to a certain degree. So I'll set the lathe up, we'll find a decent 55-degree tool and see if we can get that thread screw cut. Right, we need to bore that to the core size of the thread. So we'll measure that. We'll do it in metric, it's easier. 19mm, so it's 3/4 obviously, so we'll bore that hole to 19mm and then put some threads into it. That was the left hand thread, factory thread that we did last week was dear me, talk about a guess. That's not bad, is it really? And I'm not joking, that was just roughing it out. Right, I have got a nice hand ground 55-degree tool here that'll do the job perfectly well. We'll get it set up on centre height, get the gearbox set up and get some threads into it. Right, the tool's on centre height, I just want to touch it off nice and gently. To there. I'll zero the cross slide at that. I'll also put the DRO in, that was a compressor John. I'll put the DRO on as well and zero that. Right, once again, once we start screw cutting, we can't disengage the lead nuts. Well, you can, I'm not going to, it's easier just to leave it engaged. We'll put some thread on, I'll put some bit of feed on, start the lathe up. Right, that's it engaged, so it's start to cut a thread. Indeed it is. That's better. And we'll settle for that. It shows that we've got the right pitch. The tool will work. We'll make one out of either probably a bit of steel, I would think. I'm just going to dress these threads up a little bit, so I'm going to engage the lead screw and then stop the lathe, and then I'm going to jiggle compound slide until that tool fits in nicely like that. Right, so I've stopped the lathe with the drive on, and all I've done is I've jiggled the compound slide and the cross slide until the tool fits in there quite nicely like that. And all this is going to do basically is just take the dirt out of it, just clean the damaged bits of thread up. Should do it this time. Just taking the damaged part of the thread off, that's all I wanted to do. That looks a lot better. Much better. Right, John's happy at that. We'll definitely settle for that. I've actually found a Whitworth tap that's the right size anyway, so once I screw cut it, I can put the tap in to clean the threads up. I'm going to make one of these out of steel now. It's got to have a blank end on with a tape to fit that, so I think I'll just make a tube like that, and I'll fabricate an end and probably weld it in, because I wouldn't like to try and screw cut that thread up against the shoulder. I've got a suitable piece of mild steel bar here, we'll get it out of that. At least I think it's mild steel, it looks like mild steel. As I wasn't sure, we had to find out. I'm not quite sure what the black colour signifies. face the end up, part of it off the right sort of length, and then we can drill it and get it screw cut. Yeah, it's just made of steel, that. Very free cutting. Ideal for this particular job. I'm just going to take a cut off the outside. I'm really pleased with these tips. I've got 2 or 3 boxes given, and they do fit this holder quite nicely, so they're going to be good to use. This is the same corner I've used quite a bit now. Make sure that the parting blade is at 90 degrees to the job. Its centre height's fixed. I know it's on centre height. Probably that much, so we can shorten it or lengthen it depending on how we're going to do it. And drop it down again. Started a protest there, and all I did was increase the feed rate, not back off. And that's not too bad. That's a 16.5mm drill, a nice sharp one. You can see all the swarf coming off even. Both sides, that's a good sign that the drill has been correctly sharpened. That's the way it's supposed to work, just like that. Right, so that's 16.5, and we can bolt it from there. I'm not using the power feed because I've got the Imperial change gears in there and they're bloody noisy. Just about there, 18.6 we need it. to do, because this is a very coarse thread and that's a high-speed steel tool, I'm going to use the compound slide to put the cut on. So I've set the compound slide to the angle of 55 degrees. We'll work with screw cutting angle. And if you look at the tool, the angle of the tool there is the same as the angle of the compound slide. That's how you know it's right. So we're going to put the cut on with the compound slide, which means it's only going to be cutting on the front part of the tool. That's the way, the old school way it's done. That's the way I'm going to do it. I'm just going to touch this off and then set the gearbox up and get a screw cut. Right, so everything's set up, gearbox is set up, cross slides on 0, compound slides is ready to put the cut on. When I engage the feed nut, once it's engaged, it stops engaged until the thread's finished. Right, so I'm going to put a little bit of cut on. Then we'll move the cross slide in, reverse the lathe, cross slide back out to 0, a little bit of cut on the compound slide, lathe forward, and away it goes happily on its little way. Quite a bit of spring in this tool as well. Right, so we've just made a cut, so wind in the cross slide, reverse the lathe, cross slide back to 0, bit of cut on the compound slide, lathe forward, and so it goes on. Do a couple of spring cuts on this setting and then we'll try and screw it in.